In this video, we are going to be focusing on 20 important logarithm formulas. Starting with the first one, which is basic logarithm function. Let's assume we are given the log of b into x. The logarithm of a number x to the base b is the exponent to which the base must raise to produce that number. First, you need to do, given a number x and a base b, you need to find the exponent y such that you are going to end up with by, which is simply going to be x. What about the next one? The next one here, let's say you are asked to find the change of base formula. In this case, the change of base formula is given by log of b into x. This is simply going to be log of c into x divided by the log of c into b. This formula allows us to convert a logarithm with any base into equivalent logarithm with a difference base. First thing you need to do is to take the logarithm of x with base c divided by the logarithm of b with base c. Let's try another one. The third one. What if you ask to find the product rule? In this case, let's say we have log b into what? X and y. X multiplied by y. This is simply going to be log b x plus log b y. When multiplying two numbers, you can add their logarithm together. First thing you need to do is to take the logarithm of x with base b, add it to the logarithm of y with base b. What about the quotient rule? In quotient rule, let's assume we are given log b into x divided by y. This is simply going to be the log of b into x minus the log of b into y. When dividing two numbers, you can subtract the logarithm of the divisor from the logarithm of the dividend or dividend. First thing you need to do is to take the logarithm of x with base b, subtract the logarithm of y with base c. Next thing we have on the list is power rule. In this case, let's assume we are given log b into x to the power of a. This is simply going to be a multiplied by log of b into x. When raising a number to a power, you can multiply the exponent by the logarithm of the base. First thing you need to do is to take the logarithm of x with base b, then multiply it by a. Next thing we have, let's say logarithm of logarithm of 1. In this case, let's say you have the log of b into 1. This is simply going to be 0. The logarithm of 1 to any base is always 0. No matter what the base is, the logarithm of 1 can't be changed to any number. This is simply going to be 0. What about the logarithm of base? Let's say you have the log of b into b. This is simply going to be 1. Let's take an example with log of 2 into 2. It's also going to be 1. Regardless of the base, the logarithm of the base itself is equal to 1. What about the negative logarithm? In this case, let's say we have log b into x is undefined. For x is less than or equal to 0. Logarithm of non-positive numbers are undefined in the real numbers. So first thing you need to do is to ensure that the input value of the logarithm is strictly greater than 0. Logarithm of a fraction. That's the next thing we have on the list. The logarithm of a fraction, let's say we have the log of b, which is simply going to be 1 divided by x. In this case, this is the same thing as saying negative log of b into bracket of x. The logarithm of reciprocal of a number is the negative of the logarithm of the number. First thing you need to do is to take the logarithm of x with base b, then negate the result. What about the logarithm of a power? In this case, let's say we have log of b into what? X to the power of n. This is simply going to be n multiplied by log of b into bracket of x. The logarithm of a number raised to a power is equal to the exponent times the logarithm of the base. In this case, first thing you need to do is to take the logarithm of x with base b, then multiply the result by n. What about the logarithm of a root? In this case, let's say we have log b n into the square root of x. This is simply going to be 1 divided by n multiplied by log b into bracket of x. The logarithm of n root of x is equal to the logarithm of x divided by n. In this case, first thing you need to do is to take the logarithm of x with base b, then divide the result by n. What about the logarithm of a negative number? The logarithm, let's say we have log of b into bracket of negative x. It's undefined in the real number system. Why? Because logarithm of a negative number are undefined in the real number system. First thing you need to do is to ensure that you input the value of the logarithm is strictly positive. What about logarithm of a decimal number? In this case, let's say we have the log of b into what? 10 to the power of x. This is simply going to be x multiplied by the log of b into bracket of 10. The logarithm of the power of 10 is equal to the exponent times the numbers of times the logarithm of 10. In this case, first thing you need to do is to take the logarithm of 10 with base b, then multiply the result by x. What about natural logarithm? Natural logarithm is being denoted by ln, which is natural log of x, which is the same as what? Log e into bracket of x. The natural logarithm is the logarithm to base e denoted by as ln into bracket of x. First thing you need to do is to compute the logarithm of x with base e. What about the properties of natural logarithm? In this case, let's say we have ln xy. This is simply going to be ln x plus ln y. And what if we have ln x divided by y? This is simply going to be ln x minus ln y. Similar to the logarithm with other bases, these properties apply specifically to natural logarithm. First thing you need to do is to compute the natural logarithm of the product or quotient of two numbers. What about exponential form of logarithm? In this case, let's say we have b to the power of log b into bracket of x. This is simply going to be x. Exponential form shows the relationship between logarithm and exponentials. First thing you need to do is to raise the base b to the power of logarithm of x with base b resulting in x. What about for logarithm form of exponential. In this case, we can have, let's say, log b to the power of b to the power of x. This is simply going to be x. A logarithmic form represents an exponential equation in terms of logarithm. First you need to do is to take the logarithm of b to the power of x with b resulting in x. What about logarithm of negative real numbers? Logarithm of negative real numbers, let's say we have log b into bracket of negative x. We can simply say this is also undefined in real number system. Logarithm of negative real number are undefined in the real number system. First thing you need to do is to ensure that the input value of the logarithm is structurally positive. What about the logarithm of differentiation? In this case, let's say we have d all over d of x. This is simply going to be log b into bracket of function f of x. Close bracket, close bracket, close bracket in two places. This is simply going to be f prime of x divided by f of x ln b. In this case, logarithm differentiation is a technique used to differentiate functions that are difficult to differentiate directly. First thing you need to do is to take the derivative of log b into bracket of f of x with respect to x using the formula. The last thing we have on the list is logarithm of infinity. In this case, logarithm of infinity, you can set, let's say we are having limit of x approaches infinity as what? Log b into bracket of x. This is simply going to be infinity. The logarithm of a number approaching infinity is simply going to be infinity. First thing you need to do as x approaches infinity, the logarithm of x with base b is simply going to also approach infinity. So this is it for this problem. Thank you for watching.